Welcome to Daily Papers.
The show where we break down fascinating new research. Today, we're talking about forecasting. Predicting the future is a huge job for AI, from weather patterns and climate change to the stock market and energy demand.
And we want those predictions to be accurate, obviously. But there's a bigger problem. We also need them to be reliable and trustworthy. Can we be sure an AI's climate model isn't predicting something that violates the laws of physics?
Exactly. And the way we've been building these systems is a bit clunky. It's like a three-step fragmented process. First, we train the AI to be as accurate as possible.
Get the right answer. Makes sense.
Then, as a second step, we try to force it to obey the rules. We add these penalty terms to its training, basically telling it, hey, don't predict negative rainfall, that's impossible, or total energy can't just appear from nowhere.
So you're punishing it for making physically impossible predictions.
Right, and then as a final third step, we might try to formally verify the whole system. This is a super slow, computationally expensive process where we try to prove mathematically that the model is reliable. It's so slow, it's often not practical for real-world use.
So accuracy, then rules, then a separate check. It sounds inefficient. Today's paper, GeoCert, Certified Geometric AI for Reliable Forecasting, suggests a much more elegant solution.
It's a fantastic idea. Instead of three separate steps, the authors unify them into one single beautiful computation, and they do it using geometry.
Geometry? Like shapes and curves? How does that help with forecasting?
Okay, let's use an analogy. Imagine all possible forecasts are points on a giant flat map. Some areas of the map represent good, physically possible forecasts. Other areas are forbidden zones, the physically impossible stuff.
And normal AI models wander all over this map, and we just try to slap their hands when they wander into a forbidden zone.
Precisely. GeoCert does something much smarter. It doesn't just guide the AI on the map, it fundamentally changes the shape of the map itself.
Okay, you've got my attention. What does this new map look like?
This is the core idea of the paper. They build the AI inside a special kind of mathematical space called a hyperbolic manifold.
That sounds complicated.
It does, but the concept is actually quite intuitive. Forget a flat map. Think of a Pringles chip or a horse's saddle. It's a surface with what's called negative curvature.
A saddle-shaped universe for the AI to live in.
Exactly. And here's the genius part. This saddle is constructed so that it only contains valid, physically possible forecasts. The impossible predictions, they simply don't exist in this geometry. They're not on the map.
So the AI can't make an impossible prediction because there's literally no place for it to go.
You've got it. The learning process becomes like a marble rolling on the surface of this Pringle. It can't fall off into an invalid prediction because the very shape of its universe keeps it on a valid path. The rules of physics aren't a punishment anymore. They are the fabric of the AI's reality.
Wow. So that's how they combine prediction and rules. What about the cert part of GeoCert, the certification? How do we know it's provably correct?
That's the other beautiful part. Because the model is always moving within this safe space, the path it takes to get to a forecast is itself a proof of validity. The journey becomes the certificate.
So verification isn't a slow afterthought. It's generated for free alongside the prediction.
Instantly, which leads to the next huge benefit, speed. You might think operating in a weird curved space would be slow, but it's the opposite.
How?
That Pringle-like negative curvature has another neat property. It causes things to contract, to pull together towards the optimal answer much more efficiently. The AI doesn't waste any time exploring dead ends in those forbidden zones because they don't exist.
So it finds the best physically possible answer faster.
Much faster. The paper reports it trains up to 40 times faster than some other models, and with a staggering 97.5% reduction in computational cost. And because of this geometric contraction, it's also much more robust to noisy data. Small errors don't get amplified.
So let's recap the results. They've built a system that's more accurate, dramatically faster, and more efficient to train, and it automatically produces a mathematical proof that its forecasts are reliable and obey physical laws.
Exactly. They tested it on real-world data for energy, weather, finance, and traffic, and it consistently set new state-of-the-art results. It's a complete package.
It really changes the game. We're moving from AI systems that just give us a best guess to systems that can provide an answer they can mathematically stand behind.
It's a foundational shift. The paper argues that accuracy, reliability, and certification shouldn't be competing goals. With the right geometric design, they are synergistic properties that emerge together.
A truly elegant piece of work. The paper is GeoCert, Certified Geometric AI for Reliable Forecasting. It's a powerful reminder that sometimes to solve a complex problem, you just have to change the shape of your world.
Thanks for tuning in to Daily Papers. We'll be back next time with another deep dive into the research that's shaping our future.